Welcome to this learning video on street light installation and maintenance by Power Sector Skill Council, produced in collaboration with SEMCA. This video is aligned to the job role of Assistant Technician, Street Light Installation and Maintenance, QP code PSS/Q6003, NOS code PSS/N 6007 and PSS/N 6008. As part of the installation process, we are now going to learn the step-by-step procedure for testing of the system. Before we discuss system testing, let us first look at a scenario. A car manufacturer does not produce a car as a whole. Each component of the car is manufactured separately. For example, seats, steering wheel, mirror brakes, engine, car frame, wheels, and so on. After manufacturing each component, it is tested independently to check whether it is working the way it is supposed to work. This is called unit testing. Now, when each part is assembled with another part, that assembled combination is checked. These combinations are checked to see if assembling has produced any side effects to the functionality of each component and whether both components are working together as expected. This is called integration testing. Once all the parts are assembled and the car is ready, it is not ready actually. The whole car needs to be checked for different aspects as per the requirements defined. So we need to check if the car can be driven smoothly, if brakes, gears and other parts are functioning properly. The car should not show any sign of tiredness even after being driven for 2,500 miles continuously. We also need to check if the color of car is generally accepted and liked. We need to check if the car can be driven on any kind of roads. This whole effort of testing is called system testing. It has nothing to do with integration testing. System testing. In system testing, it verifies the entire product after integrating all components in the generation, transmission, distribution and street light installation. It also includes validating or testing according to the project requirement specifications. We use system testing for error detection and removal of errors. It is also used to determine the level of reliability. Tools. For testing of electrical systems, especially in street lights, we will use tools like Lux Meter. This instrument provides a luminance reading based on either lux or foot candles. Lux is standard unit of measurement unit for illumination. Now we are checking the open area lux value in daytime. Value coming around 1411 lux. Digital multimeter. As you are seeing, it can measure following: 1. Current DC, 2. Current AC, 3. Voltage DC, 4. Voltage AC, 5. Resistance, 6. Continuity by buzzer sound. Mega insulation tester. It helps to measure insulation resistance. Now we will discuss the step-by-step procedure for the testing of a system or various types of parts of street light installation. Testing of the system. In electrical testing, the most basic form of testing is by applying a voltage or current to a circuit and comparing the measured value to an expected result. Electrical test equipment verifies the value and logic behind a circuit. Each piece of test equipment is designed for a specific application. Heightened reliability and safety concerns have resulted in new maintenance programs and techniques. Every year, additional pressure is also put on operations and maintenance managers to provide a higher level of power system safety and reliability at lower costs. The greatest difficulty for many of these managers is to design, customize a comprehensive preventive maintenance (PM) program. Testing and electrical installation. Here, a visual inspection is carried out first to confirm that permanently wired electrical equipment is not visibly damaged and compliant with the safety requirements. Functional test. All assemblies such as switchgear and control gear assemblies, drives, controls and interlocks should be functionally tested to show that they are mounted, adjusted and installed in accordance with the relevant requirements of the standard. Protected devices must be tested to check whether they are properly installed and adjusted. Test the supply across the on-off switch. Now when you switch on a switch of a street light and nothing happens, you have to think about what could be wrong. Let us try the simplest solutions first. Make sure the bulb is good and is properly fixed. Also, Make sure that the circuit has power and has not tripped its circuit breaker or blown its fuse. When one of these issues is not the problem, it could be a bad switch, especially if the switch is old and or feels a little loose. There is a sure way to test a light switch for failure. It requires removing the switch from the circuit and testing it. Test across all joints. Check the wire. The wiring defects include bad solder joints, faulty crimps, pin contact contamination, improper wire gauge. Testing fixtures and other parts. The tests performed on fixture and other parts are circuitry check. Lighting installation, equipment and appliances, and any other tests that are considered necessary to meet the design intent. So with physical inspection and continuity testing, we can confirm whether fixtures and other parts are in working condition or not. Continuity of cable. Continuity testing of protective conductors is normally carried out with an instrument able to generate a no-load voltage in the range 4 to 24 volt DC or AC with a minimum current of 0 to 2 ampere. The most common continuity test is to measure the resistance of protective conductors. Polarity test. Polarity test must be done to verify that all such devices are connected in the phase only. Incorrect polarity results in parts of an installation remaining connected to live phase conductors even when a single pole switch is off, or an overcurrent protection device has tripped. Now you're watching we are doing polarity test. First we have to ensure that power supply is in off condition. With the help of a multimeter, we are checking terminal voltage. Voltage showing 0 volt, which means there is no voltage across the terminal. Now we are removing the light fixture and laying wire from phase terminal of light fixture up to switch terminal. Then between phase wire and switch incoming point, we will see continuity. As we are seeing when miniature circuit breaker MCB is on, then it is showing continuity, and when it is in off condition, it is not showing continuity. Means polarity is proper. Insulation resistance. The insulation integrity is critical to prevent electric short. It is generally measured between live conductors and between each live conductor and earth. You are seeing we are doing insulation resistance test between phase and earth at 250 volt DC. We have connected the Mega red probe with red color phase wire and the Mega black probe with pole body. Now we are selecting Mega at 250 volts and pressing the test button. Value coming around 5 gigaohm. Now we have connected the Mega red probe with black color neutral wire and the Mega black probe with pole body. Now we are selecting Mega at 250 volts and pressing the test button. The value coming more than 5 gigaohm. The above value shows that insulation resistance is good and the circuit is fault free. Separation of circuits. The separation of the live parts from those of other circuits and from earth should be verified by a measurement of the insulation resistance. The resistance values obtained should be identical to the values mentioned previously, with all appliances connected as far as possible. Earth electrode resistance. Measurement of the resistance of an earth electrode is done by Earth Mega. For example, by means of 2 auxiliary earth electrodes or spikes, the value should not go beyond 5 ohm in earth tester. Earth resistance testing must not be done on live system. So the system function test follows component and equipment tests using the various techniques listed above.